Hello guys. So here's a summary of the graphing properties so that you can graph them without Desmos. So if you get r equals a number, say for instance r equals 4, that's just a circle, 1, 2, 3, go out a radius of 4, and it's a circle that just has the pole at its center. So that's all that is. So a circle centered at 0, 0 with that radius. If you get theta equals a degree, for instance, let's say theta equals negative 30 degrees, I would go down to where negative 30 degrees is, and it's basically the slope of a line. And that's it. All right, let's move on to circles where the diameter is going to be that coefficient b. If it's cosine, it comes off of the x-axis. So positive would start over here, negative would be over here. So if I had r equals 3 cosine theta, I would go out a diameter of 3, and you would go through the origin and you would go through the radius of 3, and it's just a circle then. So those are the ones where you have to complete the square if you're doing the conversions. If it's sine, it'll be off of the y-axis. So let's say I gave you r equals negative 4 sine theta. Well, because it's negative, you go off the negative side, 1, 2, 3, out a diameter of 4, and just draw a circle. Okay, so that's basically circle with diameter of b. If it's sine, it's off of the y-axis, cosine off of the x-axis. Then we get to our lines. Now the lines were easy enough to figure out based on the conversions, because remember y equals r sine theta, and so r equals b over sine theta, but remember the reciprocal of sine theta is cosecant. So it's basically, if it's cosecant, which is related to sine, which is related to y, it's going to be the equation y equals whatever that b value is. So if I have r equals, say, 5 cosecant theta, I go up to a radius of 5, 1, 2, 3, 4, 5 on the y, and I draw a horizontal line. If it's secant, remember the reciprocal of secant is cosine, so it's going to be kind of the same thing. Let's do a negative 4 secant theta. So it'll go off of x equals, but now it's negative 4. 1, 2, 3, 4, and that would be a vertical line, x equals negative 4. So now we get down to our rose petals. The cosine ones are a little bit easier because you always are going to start on either the positive or the negative x-axis. So b is the diameter of the petal. If n is odd, that's how many petals you have. If n is even, you'll have twice that many petals. And they will always be equally spaced based on however many petals, 360 divided by that, so that they're equally spaced around the circle. All right, so let's say I gave you, start off with r equals negative 4 cosine 3 theta. So the negative says, and again, if you're not sure where things start, you can always plug in, say, your quadrantal angles, because that will give you where you're going to cross the x or y axis. That's sometimes a nice way to go. But really, this is going to start on the x-axis, so 1, 2, 3, but negative 4, and there are going to be 3 leaves. So 360 divided by 3 is 120. So this would be, so going backwards, they're all going to be 120 degrees apart. So this one will go here, and then this one will go over here. So this one is at 180, this one is at 60, this one is at 300. They're all 120 degrees apart. Then if I gave you r equals, I guess I should stay with the same color, r equals 5 cosine 2 theta, so there's going to be 4 leaves, and they are going to be at a diameter of 5. 1, 2, 3, 4, 5. So now that it's positive, we'll start on the positive. There's going to be 4 leaves, so there's the first, which means they're all going to be on the quadrants. They're all going to be 90 degrees apart. So 360 divided by 4 is 90. So that would be the rose petals for cosine. They'll always either start on the positive x-axis if your b value is positive, or on the negative side if b is negative. With sine, everything is going to be the same except for where you start. Because with cosine, cosine of 0 degrees is 1. That's why you start on the axis. Unfortunately, with sine, sine of 0 degrees is 0. So to figure out where to start, you always have to go 90 divided by n. Not 90 divided by the number of petals, but 90 divided by whatever that n value is. So if I gave you r equals -4 sine 3 theta, to compare with what we did with cosine, that means since it's negative, well, first what we have to do is go 90 divided by 3 is 30. So that means that's where I start. So I'm starting at 30 degrees. So here's 30 degrees, and it's 4, but because it's negative, it comes back this way. So I'm actually starting at 210. And then everyone is going to be 120 degrees apart. So 210 minus 120 actually puts me at 90. And then 120 is from here is going to be 330, which is right here. Whoops, did I go out to I want to go out to a diameter of 5. I think I missed my diameter over on this first one. Sorry about that. I think, is this 5? I didn't really count, but it should be a diameter of 5. Okay? And then I have r equals 5 sine 2 theta. So again, you'll have 4 leaves. They'll have a diameter of 5. Oh, that was supposed to be 4. Sorry, I was getting mixed up. I was looking at the 4s. So these should all have a diameter of 4. Sorry if it's not. These will have a diameter of 5. And I will have 4 of them, but where do I start? So I start at 90 divided by 2, which is 45 degrees. So in this case, I'm going out to 5. This time I'm truly going out to 5. But I'm going to do all of my 45 degree angles because they're all going to be 90 degrees apart. So then I'll be over here at 135. And I'll be down here at 225. And over here I will be at 315. So basically 360 divided by 4 is 90. So they're all 90 degrees apart. You start at 90 divided by n. And then you count from there. All right? Okay, now for our cardioids and limicons. And basically, they all follow the same rule. It's just about what results. So again, this is cosine, so it's going to come off the x-axis. Realize these ones also work really well if you just want to plug in. If you're not sure, you can plug in your quadrantal angles, and it'll tell you where you cross. But because these have such a nice pattern, you're going to be doing A plus B, you're going to be doing A, and you're going to be doing A minus B. That's really what it boils down to. So if I give you, cardioid A and B are the same. So if I give you 3 plus 3 cosine theta, so 3 plus 3 is 6. 1, 2, 3, 4, 5, 6. So I start here. So this represents A plus B. Regardless of whether A or B is negative, you ignore that. You look at it in absolute value. So A plus B, and that's because cosine of 0 is 1, so you end up with 3 plus 3. Cosine of 90 and 270 is 0, so that leaves me only with A on the sides. So here's A at 90 and A at 270. And then 3 minus 3, because cosine of 180 is negative 1, that brings me back to the origin. So you get a little dimple. You kind of go in and around. So that would be 3 plus 3 cosine. If you saw a negative, the only negative that would matter is the one that comes right in front of the cosine. If the A was negative, it would be symmetric vertically, which you wouldn't even notice. So it's like rotating a circle on itself. You wouldn't notice it. But if the cosine part is negative, what happens is A plus B just moves to the other side. So I'm here at 4, A plus B. My sides are at A, which is 2. And then 2 minus 2 is still 0. So everything, again, you ignore the negative when you're doing your addition and subtraction because that just represents a reflection. You're still going to have the A plus B, your sides will be A, and the dimple happens at A minus B for all of them. And this is going to be true sine, cosine. The only difference is sine is going to come off of the y-axis. So 3 plus 3 sine theta, I'm going to go 1, 2, 3, 4, 5, 6, go out 3, go out 3, 3 minus 3 is 0, so you get an upside down cardioid, or, well, that had a little blip in it, but it's good enough. Down here we'll do the same, 2 minus 2 sine theta. So if you do have that negative, it just means go to the other side. So A plus B is 4, 1, 2, 3, 4. My sides are 2. 2 minus 2 is 0. And you just get a smaller one, but reflected over, okay? Limacons, same deal. The only difference here, so how do I know if I have a loop or not? It's when you do A minus B, because A minus B, if you get a negative number, remember the negative radius pulls back by 180 degrees. That's where the loop comes in. So let's see, if we had R equals 3 plus 2 cosine theta, so we do A plus B, which is 5, 1, 2, 3, 4, 5. My sides are still going to be A, so that's 3, and that's 3. 3 minus 2 is 1, positive 1. So at 180, I'm going to be at a positive 1, and you get a dimple. So this is a dimpled limacon. It's just like a cardioid, except you're out a little bit further than the pole. But if I switch things around, let's say I had 2 plus 4 cosine theta. So 2 plus 4 is 6. 1, 2, 3, 4, 5, 6. And my sides are going to be at 2. 1, 2. Now 2 minus 4 is a negative 2. So at 180, I come back. Because I came back, it means you come around, you go through the pole, you loop at that point, come back through the pole, and finish it off. All right, so that's when you get a loop. And it comes out naturally because A minus B is going to be a negative number. So now if we do sine, exactly the same thing. The only difference is you're going to be off of the y-axis. So let's say I threw in a negative here. Same thing, it just means I'm reflected on the bottom side. So 3 plus 2 is 5, so that puts me down here. My sides are at 3. 1, 2, 3. 3 minus 2 is a positive 1. So at 90 degrees, I'm out here at a positive 1. And then you have a dimple. So this is your true, there we go. Not quite symmetric, but you get the idea. And then if I did the same over here, R equals 2 plus 4 sine theta. So 2 plus 4 is 6. 1, 2, 3, 4, 5, 6. My sides are at 2. And 2 minus 4 is a negative 2, which brings me, and that's because at 270, sine is negative 1. So I come back inwards. You come around, you go through the side, the pole, you loop, come back through the pole. I always seem to do it really big on that side, but you get the idea. Okay? Hope that helps.